You should also be able to make a graph called an ogive when dealing with quantitative data. Now, an ogive is specifically, it's a line graph, much like the frequency polygon, but it's a cumulative frequency line graph. So instead of frequency on the vertical axis, we now have cumulative frequency. And here is, again, the data about the amount of dollars spent on music per year. And this is our table with just the specific columns that we need. The cumulative frequency, and again, we're going to need the midpoints. The midpoints are going to be the values on our tick marks on the horizontal axis. So plot the midpoints on the horizontal axis. And also, you'll see number 2 here as well. We will talk about that as we get to it. So let's first look at our cumulative frequency axis. We need to go all the way up to 20. Maybe we'll jump up by 4s, let's say. So this, of course, is 0 here, 4, 8, 12, 16, and 20. And then the midpoints are going to be on our horizontal axis. So, of course, this value right here is 0. So let's make this right here 49.5. And again, 0 and 49.5 are apart by about 50 almost. And then we're going up by 100 between successive midpoints because that was the class width. So we'll go about double that size there. So we've got, this is 149.5 and 249.5 all the way up to 649.5. And I'm just going to offset these a little bit so you can see this a little bit better. So this is 449.5, this is 549.5, and this is 649.5. Now, we put in dots at the respective heights. So the 49.5 midpoint is the midpoint for the $0 to $99 spent per year class, which has a cumulative frequency of 6. So we're going to put dot right here at 6. And then for the 149.5 bar, we got a cumulative frequency of 8. For the 249.5 bar, we've got a cumulative frequency of 11. 15 for the next one. 17 for the following one. Of course, this was on grid paper. It would be easier to get it nice and precise. 18 for the following one. And then finally, 20 for the last one. Not quite a straight line, but fairly close. Remember to connect each pair of adjacent points with a straight line segment. Do not draw a smooth curve between the points. And now, the other criteria for making an ogive is number 2 here. You need to start on the horizontal axis one class width to the left of the first class midpoint. So again, the class width for this data set was 100. So we need to go 100 to the left of this 49.5 right here. So 100 to the left of that would put us at negative 50.5. And let me just quickly erase that because it's a little hard to see. Of course, we know that's a 0 value right there. Negative 50.5. So we're going to bring it down to the horizontal axis, one class width to the left. And now we have an ogive here. Notice that I did not say to bring the ogive graph down to the horizontal axis on the right. You do that with frequency polygons, but you do not with ogives. And there's a logical reason for it. An ogive is a cumulative frequency graph. If you were to add rows to this table here, no matter what, even if there was a frequency of 0 for the next class, the cumulative frequency would not drop below that 20 because it's always the class frequency plus the ones before it. So ultimately what that means is ogives never decrease. They can either increase or flatten out, but they cannot decrease. So that makes sense then that you cannot bring this down to the horizontal axis to the right. We now have one final type of plot that you should be able to make with quantitative data. It is called a stem and leaf plot. Notice here that I switched the data. Instead of talking about the amount of money spent on music per year, I'm now using the ages of people at a house party. And there's only 12 people at this particular house party. You could make a stem and leaf plot with the data on the amount of dollars spent per year for music. However, it's a little bit more messy because of the range of numbers there. And I want to keep the stem and leaf plot very simple. So you would expect something like this on any coming quizzes or exams. So let's look at this data set. So you've got a 31-year-old, 32, 32, 39, all the way up to a 71-year-old at this house party. We want to make a stem and leaf plot to represent the people at this party and their ages in particular. So with the stem and leaf plot, the leaf part of the number is almost always the first digit to the right. This is what we call the leaf. You can possibly define it differently, but for us, the leaf will always be the digit furthest to the right, and it'll be just that one digit. So for example, the leaf of that number 41 is 1. The leaf of this number 40 is 0. And the stem is what's left. So this is the stem of this number, and this is the stem of this number. Let me write that in. So what we need to do is separate the stems and the leaves. That's what you see here. We'll get to this key in a minute. But separate the stems and the leaves, and we want to first write down all the stems possible. The stems here in this data set are, we've got a 3, we've got a 4, we've got a 5 right here, and we also have a stem of 7. Now, because this is a quantitative data set, we are not going to skip over the stem of 6, so we're going to write it in. So we go from 3 to 7 in our stems. So 3, 4, 5, 6, 7. And then within each stem, so we'll focus on the 3 stem right here, we put the leaves next to it. And if there's any repeated leaves, we put them in there, and we also put them in order. The leaves in this data set that go with a stem of 3 are 1, 2, another 2, and a 9. So we're going to put those leaves in next to the stem of 3 in order, and also repeating anything that repeats. So we got a leaf of 1, a leaf of 2, a leaf of 2 again, and a leaf of 9. And then the leaves that go with a stem of 4 are 0 because there was a 40-year-old, a 1 because there was a 41-year-old, 2 2s because there were 2 42-year-olds, and then a 7 because there was a 47-year-old. Notice that I'm also spacing these out evenly each time. You'll see why I did that when we interpret this in the end. For the stem of 5, there was 2 leaves, the 51 and the 52. So the leaves were the 1 and the 2, that is. So we've got 51, 52. With 6, there were no 60-some-year-olds, so there's nothing that goes here. And then there was one 71-year-old, so there's a leaf of 1 that goes with a stem of 7. Now, the stem and leaf plot is not complete. We have to always put in a key. That's what this is here. You got to let people know what this means. So if you write something like 3 vertical line 1, what does that mean? So 3 vertical line 1 is the number 31, or you could write equals the number 31. And the reason we got to do that is because imagine this data set being the amount of rainfall in a particular month in several different counties. These numbers could be like 3.1, 3.2, 3.2, 3.9, 4.0, so on and so forth. So 3 vertical line 1 would mean 3.1, not 31. Right? So the key is important to have in there. Again, usually this will say equals 31, but that's fine. You can write it in words. So 3 vertical line 1 represents the number 31. So it tells you what each of these numbers down here means. This all together here is our stem and leaf plot. So what's the value of such a plot? Well, if you turn this sideways, I'm going to draw in something here that's not actually part of the graph. Look at this. Again, you don't draw in these lines here when you do a stem and leaf plot. This is just for analysis. If you turn your screen sideways, notice this is essentially a bar graph. You have the highest peak is here in the 40-year-olds, and there's a lot of 30-year-olds, and then it decreases pretty quickly, and then there's a gap here, and then there's only one 70-some-year-old. Now, so not only is it like a bar graph, but it's even more valuable in the sense that you still get the raw data values, right? You still see that you have a 31-year-old, a 32-year-old, a 32-year-old, a 39-year-old. Whereas if you make a histogram and you've grouped the data, you lose the raw data values. Whereas with a stem and leaf plot, that doesn't happen.